Section 2.2 deals mainly with subsets and working with subsets. So before we get to subsets, I want to talk about what the complement of a set is. And in order to talk about complement of a set, I need to talk about something we're going to call the universal set. Now, I'm not going to write a definition for this. It's the universe. So, and it changes depending upon the problem you're working on, but whatever context you're working on, it is the biggest set possible. All sets live within it. All right, so it's the universe. Now, so now we're going to define the complement of a set A and it is denoted with A and then a prime mark. And it's as soon as you see that, so it's not A, it's a different set than A. But as soon as we see that prime mark up in the superscript, we say complement of A. All right. Is the set of elements and universal set, incidentally, is denoted by a capital scripted U. So I just put curly ends on it. So it is the set of elements that are in the universal set that are not elements of A. So using set notation. So again, from the video, you would have watched the 2.1. We use braces. And everything inside the brace will belong to the set. And I'm going to use set builder notation. So again, from that video, it's a way to generate the elements of a set. So this is red, X such that X. So to belong to this set, this means element of, kind of a funky looking E, small e. So that reads element of, belong to the universal set. And X is not an element. So to represent that, I use the element of symbol and put a bar through it. Not an element of A. Close brace. All right. So, example, if I had a universal set, we'll keep it simple, and it had the elements 1, 2, 3, 4, 5, and a set A within there, and it's got the elements 1 and 2, then a complement. And so you can say a complement or you can say complement of A. Either phrasing is correct. Would be everything else. It would be 3, 4, and 5. Now I'm going to introduce a visual way to represent this. Now, and on Monday, we're going to do much more with these. Something we refer to as a BENN, and it is BENN diagram. And it is a visual way to represent sets. And what we use is a rectangular box. Everything within that box is the universal set. So depending upon the book you pick up, you might see a U down here, a U here, but this represents the universal set. So everything else lives within it. So if I were to draw a Venn diagram to represent a complement, I would use a circle. Everything within the circle is the set A. And then what you do is you're representing what the elements are in the particular set you're using the Venn diagram to represent it. You shade it. So since we're wanting everything outside of A in the universal set, I just would shade everything outside. And that would be a visual way to represent a complement using a Venn diagram. And again, we're going to do a lot more with those Monday and Wednesday. So questions on this so far? All right. And I'm going to turn the page. If you need me to turn back, let me know. So on the video that you would have watched on 2.1 of me lecturing on 2.1, I did talk about subset. So I'm going to expound on that and go into a little bit more detail. There wouldn't have been any problems pertaining to subset on the exercises of 2.1, but there will be for 2.2. So let's write a definition. A set A is a subset of a set B if all the elements of A are in B. And we denote this, right? Just like we read a book, left to right. A, and then I use a sideways U and a line underneath of it like this. So that this is red. A is a subset of B. Now, one thing that you missed in the video was, and I did it with the class that I was lecturing to, and I had them, we took a set with 3 elements, and I said, write down every possible subset. And very, very rarely does a class, even one person in the class, ever get that question right when I ask it. And this is why I do it. It's kind of one of those things, kind of learning by, make a mistake and then figure out why we made it, so we don't make it anymore. And they all, the entire class overshot the runway. They had way too many elements or way too many subsets listed. And so if you watch the video, the first thing that we got to talk about was that order doesn't matter in a set. If I've got the set with 2 elements and it's A, B, if I write it B, then comma A, it's still the same set. As long as all the elements are in there, you represent them. Doesn't matter the order which you write the elements. So that doesn't make 2 different sets. So that was the first thing. And then turned out there are 8. We wrote them all down, 8 subsets to a set with 3 elements. The one set that everybody always misses on when we start this is considering a set with no elements. All right, so that we refer to as the empty set. Usually a circle with a line through it is the way we represent empty set. Now you can also use 2 braces with nothing in between. I use this. If you ever, most folks that I know that have been in the military, that's how they make their zeros. And zero is if you have a set with one element, it could be zero. It is a number. So, so if you make your zeros this way, then use this as your if you're writing it out. But generally, in my math lab, you're going to see this symbol representing the empty set, the set with no elements. Because there's no elements, it is a subset. And we use this phrase in mathematics, we say trivially. Since it has no elements, it's automatically a subset of every set, including itself. Side note, don't mix these two. That is, don't put this inside here. That means something else. It's referred to as a power set. And we're not going to mess with those right now at all. So, but don't mix those two, either one or the other. All right. So as I said, if you had a set with 3 elements, there are 8 possible subsets to that set. And what I didn't do in that video was actually have a systematic, I just kind of wrote them all down and then said there are no other possibilities. But what I didn't do was systematically figure out what the 8 are. So I want to do that right now. Now, in doing this, what I want to come up with using inductive reasoning is figure out a pattern so that I could come up with a formula that, given how many of our elements, or again, what we call cardinality of the set, the number of elements within the set, as long as I know how many elements I have in the set, I could use this formula to say, then I have this many subsets. All right, so here we go. I'm going to go back to the problem that I had worked on 2.1 in that video. And say, okay, let's say I've got a set with 3 elements. We'll just call them little a, little b, little c. Always separate elements with a comma. And again, the order doesn't matter what you write. All right. So I'm going to systematically figure out how many subsets we have to a set with 3 elements. So what I'm going to do is I'm going to ask a question. And I'm going to say, let me do it right here. Is that element, little a, an element of the subset of a subset? Question mark. So there's 2 possible answers to that, yes or no. That's it. And so I'm going to use branches here and say yes or no. All right. Then I'm going to move to the next element, B. Ask the same question. Is B an element of subset? But in asking this question, I have to acknowledge I've already asked the first question. That is, so, and it's been answered. So there are 2 possibilities to the question: is B an element of the subset? But off of each of these 2 possibilities, meaning a yes or a no. And then if I had answered no on that first question, then I would still ask the question, is B an element of the subset, yes or no? And then we're going to do the same thing for that last element, C. Is C an element of subset? So same thing, 2 possibilities here, but off of each one of these, just depending on how things went. So yes, no, yes, no, yes, no, and yes, no. Now, if I start here and follow along every possible path, I'm going to come up with all the subsets. So probably could have made this a little bigger. All right, so what I mean is start here, go, okay, is A? Yes. Is B? Yes. Is C? Yes. So that is itself. And a set can always, by definition, be a subset of itself. So that is itself. And then I'm just going to continue on. Yes, yes, no. So that is the subset with just A and B. Yes, no, yes. That's the subset with A and C. yes, no, no. Sorry, kind of cramming that in there, but that's the subset just with A. All right, so I've exhausted everything from that path. I'll go to this one. No, yes, yes. So that's the subset with B and C. No, yes, no. That's the subset with just B. No, no, yes. That's the subset with just C. And then clearly one choice has to be no, no, no. That is the empty set. And there's my 8 subsets. And so from there, what I notice is it doubles for every element I increase one element by, the number of subsets to that set doubles. If I had the empty set, that is no elements in it. And when we say double, that's a power of 2. There would be one subset itself. If you have one element in a set, then there are 2 possible subsets, itself and the empty set. If you have a set with 2 elements, there are 4 possible subsets, 2 squared. If you have, as we just worked out, 3 elements, then there are 8 possible subsets. It just doubles every element you increase by. So if I said I could continue on without writing it all out. If I had 4 elements, notice there would have to be 2 branches off of each one of these. And so I went from 8 to 16, or 2 to the 4th. There would be 16 subsets. If I had 5 elements, it would double again, 32. 6 elements would be 64. 7 elements would be 128. 8 elements would be 256. It doubles every time, but it's a power of 2. It's 2 to the power of the number of elements within the set. So we could say, based on our observation, that the number of elements to a set is, I'm going to go 2 to the power of n, where n is the number of elements to the set. So I'm going to write this out as where n is the cardinality of the set. Again, remember, cardinality just simply means the number of elements in the set. It's just a big fancy word for that. Any questions on that? Okay, so I'm going to turn the page unless there's an objection. All right. So that will enable me, now that we have formally defined subset, to formally define set equality when 2 sets are equal. All right. Let's see how we'll define this. All right. So let's say given sets A and B, A equals B, if and only if A is a subset of B and B is a subset of A. They're subsets of each other. The only way that could happen is if they're subsets of one another. Then they have not only the same number of elements, but they're exactly the same elements, element for element. So that's our formal definition of set equality. Now I need to take the idea of subset and look at one special case of subset. So, and we needed to set equality to define this. So if I have some set A, we're going to say set A is a proper. Sorry, I'm having trouble with my tablet. Set A is a proper subset of the set B if first A is a subset of B, all the elements of A are in B, and A does not equal B. So what that says is B has something A doesn't have, something beyond the elements of A. Now, it is denoted, written, we use a sideways use only. So it kind of analogous to less than or what equal to. In this case, we take the word equal part out. So when you see just the sideways U, what you know is, okay, A is a subset of B, but not only that, it's definitely not equal to B. It's got, and it has to have less elements than B for sure, because B's got to have something that A doesn't have. So a set can be both a subset of A and a proper subset of set A. You'll have problems in the homework of 2.2 where it asks, it gives you two sets, and you want to say, place, is it just a subset of A or a subset of this set? Is it a proper subset of this bet? Is it both or is it neither? Okay. Now, so if I were to calculate all the subsets of a set, we know that is 2 to the power, which is the cardinality of the set, how many elements it has. So the only one you wouldn't count is itself. So the number of proper subsets to a set is still, you would go 2 to the n and then take away 1, and the one you're not counting is itself. Any questions? What I've covered thus far. All right, so I'm assigning all right. 6th. So I'm assigning 2.2, and making it due on Monday. So 2.2 will not be part of 2.2 will not be part of the midterm grade. So I won't put it in manage incompletes, though try definitely to work on the problems prior to Monday's class. 2.2 is now assigned. There's a fair number of problems in 2.2. Just again, it's just the concepts that I just went over today. And most of them are fairly quick, easy problems to get through. Sometime between now and Monday, I will send out information on the paper and a list of names and instructions on how to proceed. Basically, it's first come, first serve on the names. Everybody's got to have their own name to research. What I'll ask, and again, I'll write this in the email, is that you give me 3 names, rank them 1, 2, 3. So that way, if somebody has already picked your first choice, I'll then move to your second choice, so on and so forth. The paper itself is not due to the end of the semester. That is the last regularly scheduled class. And if we're in the classroom, I always ask for a hard copy. It's just easier to read it that way. But if we're virtual, which I assume we will be, you'll just email it to me, and I'll put it in a folder on my computer. And then that grade, before we get to finals week, I'll have, or during finals week, I will go, have gone over the papers, and that grade will be added on my math lab in the grade book. So remember, that's 10% of your overall grade. I have a slot for that to put it in. And in and of itself, as long as you address what the paper needs to address, which is just biographical information of the mathematician, where were they born, where did they go to school, things about their life, that sort of thing. And then spend a couple pages talking about who influenced them and who in turn did they influence. And this, again, I'll get a written attachment with a written description of what I'm telling you now. It's 4 pages length. That does not include works cited page or a cover page. That's 4 pages of text. Require a minimum of 3 sources. Back in the old days, I used to require at least 1 book. So I don't do that anymore. It is internet based. I do specifically ask you not use Wikipedia as a source, since anybody can type into Wikipedia, and so it's not verified, information. It is a good place to go to find sources though and get a start. And then it definitely will have to be documented because you are using sources in your research. And remember, whether it's a direct quote or a paraphrasing, you have to cite where you pulled that from, using, and I don't care whether you use MLA or APA, both, they have differences certainly between the two, but it's parenthetical citation, then followed by a works cited page, at the end of the book or at the end of the paper. So that's all I have for you today. I'm not going to cover 2.3. That will give folks between now and Monday, if you need to work to catch up, you've got time to do that. So the next class will cover 2.3, and there is a quiz that I'll assign as well. And so from there, I would just say, well, that's all I got today. So if you want to jump out of here, you're free to go. If you want to stay and ask some questions, feel free. I will stick around and ask questions on any past homework that you'd like me to help you with. So otherwise, have a great weekend, be safe, and I'll see you Monday.